Hello guys, KNOCKCAT this side. So today we are going to solve today's GFG POTD and it is check if frequency can be made equal. So the question is, it's a very straightforward language and it says that we are given a string S which contains only lower alphabetic characters, and this is a very important observation to make here. We have to check if it is possible to remove at most one character from the string in such a way that frequencies of each distinct characters become same in the string. It is saying, can we actually remove at most one character? That means we can remove zero characters also and we can remove one character also. At most one means in Hindi if I say ज़्यादा से ज़्यादा एक character we can remove. So we can either remove none of them or we can remove one. So we can remove actually one character from this string, and we need to uh, tell, is it possible that on removing one character from the string or zero character, do all the frequencies of these characters are equal? So let me come to the like an example. So like if I they are saying by reducing at most one, all frequencies would be same. All frequencies should be same. At most one, at most one means zero or one. So for this x, y, y, z, the frequency of x is one, the frequency of y is two, and the frequency of z is one. So if you remove zero characters, then none of since already the frequencies are not same, so zero is of no help. We have to check for that can we remove one. If I remove one from here, the count would be 0 to 1. If I would have removed this one, then I would be having 1 1 1. So like we can clearly see decrementing frequency of y, decrementing decrementing frequencies of y, decrementing y, we have obtained a frequency which is in which all the characters have same frequency. Let's consider a different example. This here also we have x, we have y, we have z. The frequency of x is 4, the frequency of y is 2, and the frequency of z is also 2. If I would have removed this to 3, 2, 2, like if I remove 0, then they are not already equal. So this is not a, we have to perform an operation. If I have removed this, then it would be 4, 1, 2. And if I would have removed this, then it would be 4, 2, 1. So none of the configuration give us a desired result where every frequencies are same. So this is not possible and we will return false. Return false. Let me consider one more example with you. What if we are given with a case A, B, C, D, E, and E? Here, a frequency of A is 1, frequency of B is also 1, C is also 1, D is also 1, E is 2. So if we can clearly see they since frequencies are not equal, so we have to perform one operation. So it is better. The intuition behind it would be like since we can only remove one character, so which character to remove? So can we do something that we can check for each character and we reduce each character frequency by one and check is now all possible frequencies are same or not. What I meant to say, can we do something like this that I go on each character frequency and I decrement it by one, because we can only remove at most one. And since this is the case where all frequencies are not equally already, that means 0th case is out now. 0 case is out. These are not equal. So I have to think of something. Can now by removing at most one character, I can achieve something so that I can do something so that every frequency become equal. So if I decrement this frequency, this would be 0. And now my frequency count would be 0, 1, 1, 1, 2. This is not possible. If I have decrement this one to 0, then my frequency count, since I can only remove 0, so this has to be 1 again. 1, 0, 1, 1, 2. Again, this is not, this is not. If I would have decremented this, then these two 1 would be 1, 1, 1 only. This would be 0, 1, and 2. This is not possible. For this also, if I would have this 0, these all will be 1 only. This will be 0 and this will be 2. Again, none of them are same. What if I would have decrement this and I have got 1? So if that the case, these all are 1 on 1, and now this is also 1. This is a correct configuration. Why? Because we removed only one character, and this is like, now I have removed one E. Now I have removed one E, and since now I have removed one E, each character has a frequency of 1. So now we have find this configuration. So as I tell the intuition, can I do something where I decrement character frequency? And by decrementing that frequency, is it possible now each frequencies are same? So this is the exact thing we need to implement. And now come to that observation that I made there, that we only contains lowercase alphabetic characters. Lowercase alphabetic characters means from we have only characters from A to Z. So since we are dealing with frequencies, I can use a map to maintain their frequency. I can use a hash map in Java. I can do a dictionary in Python. But since we have A to Z and we know there are only 26 characters, can I maintain frequency using a frequency array? If I create a frequency of 26, is this would be sufficient? Yes, this is going to be sufficient. So we can just make frequencies in this frequency array, and by just using a simple syntax, that is frequency of ch, let's say it is current character minus a plus plus. So this will, if I have taking that this taking this syntax, you need to remember this. And if I take that our example of a b c d e and e, so we have a and ch is a, and I'm saying a, so this will be the HI value. So a is also 97 and this is also 97, so we will actually get frequency of 0. And if I have, let's say, the frequency array here, this will be from 0 to 26, this will be from 0 to 26, and this 0th index, 1 index, 2 index, 3 index, 4 index, up to 26. So 1, 2, 3, 4, up to 26. So it is saying at 0 index increment my count, so it would be 1. Now my ch would be, next time my ch would be b, so b, and I am minus for b also with 97, because SK value of a is 97 and we know for b it is 98. So 98 minus 97, this is actually giving us index 1. We will increment its count because initially they all are 0. Initially these all are 0. Okay, this is simply next time. So this is an intuition that since we know that there are only 26 characters, why not check for all 26? Can I actually remove one of them, their frequency, and now check, can I achieve the desired result? Next time I would be having at C. We know C's SK value is 99. Again, for A is 97. So we will get actually 2. This will be become at index 2, our count will be become 1. Similarly for D, SK value is 100 minus 97. We will be getting 3. At 3 we will become 1. Now it's an interesting case. 101 would be for E minus 97. This will give us 4. This count will become 1. Again, again I will come at here. It will be 101 minus 97. Again, sorry for bad writing. It will again come as 107 minus 97. We will again get 4. It will say make index increment my index 4. This will now become 2. At this, now we have maintained all the frequencies. Now we only need this, and I will also maintain a variable named as max frequency. Max frequency. So in this case, the max frequency is 2. Since we have also to check, we have to check for 0 and 1 case. So first of all, do I need any operation? I will not be needing any operation if all the characters are already equal. So I can just iterate my frequency array from I equals to 0 to 26, because now I know it's from 26, and I will check that if my frequency of I is greater than 0. Why? Because if we have 26 frequency array, but having values from 0 to 25, what if we don't have f in our array? As I've already said, the frequency array is already filled with 0. So frequency of f is 0. So f is 0 means we don't have f in our string. So why to check that for? So we will have to check if my frequency of I is greater than 0 and the frequency on it will be equal to my max frequency. So if that's the case, that means we don't need to perform any operation and we can just return true. The interesting case would be this one when we have to actually perform. The interesting case would be okay. Wait a minute. The interesting the interesting case would be this one when I actually need to check for have to remove one. So this is our array. Okay. I can again do the same thing, similar type of thing from I to 26, and here I can reduce every character frequency by one. I can reduce every character by frequency by one. Okay. So let's say the updated frequency would be this index, that would be frequency of I minus one, because we can actually remove one character. So I am removing this character. Assuming I am removing this character, now I will be checking that again. For checking, I need to iterate my whole frequency array from I 0 to 26, and I have to check, and I have to check, and I have to check now. Do all the frequencies are equals to up? All the frequencies of j, this would be j, are equals to up, because up is the modified frequency. What I am doing, I am performing the operation in my up. I am actually decrementing my 1 to 0, and now I am checking, do my all frequencies are 0? Because if that's the case, so just by removing my first character, we have achieved the desired configuration. But if that's not the case, if that's not the case, I will have it. Let's say I would have a variable name as OK here, and that is actually set to true. That is actually set to true. And if this condition violates, then I will make my OK as equals to false. So after the iteration, if OK is false, that means we have not achieved the desired configuration. I have to make this frequency again as 1. I will come to where I will decrement this frequency, or like put up as frequency minus 1. So up will contain now 0. And now I'll compare this 0 with all the frequencies. Is it possible? Similarly for this, but when I will come to 2, the updated frequency would become 1. And now I will be checking 1. Yes, 1 are same. 1 is same. Let me take, uh, we will came to here. Yes, 1 is same. Again, I came to here. Yes, 1 equal to same. 1 same. 1 same. And since for this, the updated frequency is 1 only, because we actually perform the operation here. So same. So by this, and so our OK would be, our OK will never violate. So if OK is true, we can just return true. The simple intuition is check for zero case. For zero case, we are not removing any character. That means my all frequencies should be equals to my max frequency, should be equivalent to max frequency. And where I can actually remove one, since we have only 26 characters, why not check each and every character and reduce their frequency by 1, reduce their frequency by 1, and now check reducing the current character frequency by 1, can are now all the characters have same frequency. So that is the only intuition. And now let's move to the code. Okay, I might be retrieving if it got okay. Similar thing. What I did, I maintain a vector. You can say an array and of 26, since we have only lowercase alphabet characters. Now I have also a variable name as max count, because I maintain the maximum frequency achieved till far. I'm iterating my s. I'm doing the same particular stuff that I taught you here, and that is this particular syntax. This is equivalent to frequency of ch minus a only, and plus plus. But just it's my way of writing. I do pre-increment. Uh, you can do this also. Like, no need to confuse over this syntax. Max count, I am updating the maximum frequency. Now I am checking for if already all are same. So I have already set my flag to true. I know the maximum count. If already all frequencies are same, then if frequency is greater than 0, that means this particular character exists because initially my all frequency array would be 0. And so if I get these counts, these will be 1, but the rest will be 0. That means these never occur in my string. So it has to be greater than 0. It has to be present in my string. Now I'm checking if my frequency of I is not equals to max count. That means false. That means all frequencies are not same because if maximum count is this, all frequencies has to be equal. That means now we have to move to, if that's the case, I would have written true here only. All frequencies are same because then this would never become false. So since this didn't, I'm assuming that if this fails, not all character frequency, like for this case, we take A, B, C, D, E, E. For this case, it this will be false because for E we have maximum frequency as 2, and when it will compare with this one, they are not equal, so it will return false. Flag will be false. So this condition will never true. So now the same thing I am doing here. I am iterating till 26. If my frequency of I is greater than 0, that means I can actually this character is occurring in my string and I can actually reduce its frequency by 1. So current count having 1 less frequency. And now I am saying initially okay is true. And now from 0 to 26, I am checking the same thing. Do like like this only. If my frequency of j is greater than 0, if that character exists in my string and frequency of j is not equal to current count, because I am checking if I reduce frequency of this by 1, are now all the frequencies are same. We can, if that case is failing, we can just say okay equals to false and we can say break. I also write j not equals to I. Why? Like I am making current count, I am making operation at this particular index and I am comparing current count. We know we will be performing operation on ith character. So I am comparing ith character by all the characters. We know that 5, if I make it 4, and now I am comparing 4 with all the occurrences of string, but for this would be 5 only, so this will violate. So I am eliminating this one, that because this is the current character where I'm operating the operation, applying the operation. So if it is greater than 0 and my frequency of j is not is equal to current count means I have removing the frequency by 1 of this ith frequency, and since I have possibly applied the operation on this character, so I am checking that now the frequency of this character is equivalent to all the characters or not. If at some case it is already equal, since when we consider this case, at this instance, when I make it 1, all frequencies are same. So my this okay will never become true. Sorry, this will never become false. And then if we have okay, we can just return true. That means yes, by performing this operation, now when I reduce one frequency by of this character, all the remaining characters except this character have same frequencies, provided they are in my string. So then this okay will never become false. That means this is possible and we can return true. And after doing all this entire stuff of removing at most one character, still we don't find the answer, we can just return false. So I hope the intuition is clear. It's checking for 0 and 1 case. Why 0? Because at most 1. So 0, we take a max count so that each one are equal or not. And for this, if since we can only remove one character and we have only 26 character, why not check for each character that if I remove your frequency, if I remove that particular character from my string, then the frequency I would have of that character is equivalent to all of the remaining character or not. So if that's the case, we can just return true. So I hope this now makes sense to you. So if I have to look for the time complexity, the time complexity is order of 26. Let me write first order of 26 plus order of 26 cross 26, which will be equivalent to order of 26 cross 26. And if I have to write for space complexity, this would be order of 26. So order 26 because we are actually constructing this frequency array, and oh sorry, order of n. this will be order of n is a string length, then we are doing 26, so it would be actually order of n. This will be larger because. So what we are doing for auto, we are actually maintaining the frequency array, and since the string length can be up to n is 1e5, so at worst it would be 1e5. So this thing is an order of n. This is order of 26. Why? We are checking for the zeroth case that all the frequencies are same or not, and order of 26 cross 26. We are removing. It's like we are decrementing the current character and checking if now the current frequency count is equivalent to all of the other frequencies. If that's the same, then by removing a particular character, achieve a same. And this is the same thing. Can be at most one character. So we are checking for every character and removing its one frequency and checking now all the frequencies are same or not. So this is in order 26, but which will give us order of n only because this would be larger. So we can say order of n, and the space complexity is order 26 since we are maintaining a frequency array. So I hope this thing is clear to you. The intuition is clear, and the everything I think you have clear. Why we check for the zeroth case, we handle it during the max count frequency, and the one case we are checking for each frequency. I am decrementing. You can say we are removing one character and checking if the updated frequency, because the updated frequency will be frequency of I minus 1, is that updated frequency is equal to all the remaining frequencies. So if that's the case achieved, then one character, by removing one character, we achieve frequencies of all string as equal. So I hope I was able to make you understand this problem. Although this thing of making frequency array is a very, I will say, this thing you will record in many of the problems, and the observation for this is lower activity characters. So we can just do it in 26. So that's it from my side. And I hope you will able to understand the intuition and also the code. KNOCKCAT, that's right.